Moving on, I have my 3 facts about these triangles. And so now I'm ready to prove that they're congruent. That's just because side, side, side. And then so now that I have these triangles are congruent, then I can use CP/CTC right after that. So I've got my game plan. This is like an outline, like an English class. You don't just start writing your final draft. You brainstorm, you do a rough draft, and then once you feel comfortable with how it's going to flow, then you put it into your final draft. So this is extremely important. This is you coming up with that rough draft, you coming up with a game plan. So from there, I'm going to, it says write down your both given, so I've got segment JL is congruent to segment KL, and then point M is the midpoint of JK, of segment JK. So now, just like in our game plan, we knew that this was just a freebie. This was just the first part, or first of 3 parts that we knew are congruent of these 2 triangles. But we said that our second given implied something. It implied the second. So again, this shouldn't be a shock that they wrote this here. This should just line up perfectly with your game plan. So segment JM is congruent to segment JM. This is definition of a midpoint. In a proof, if we talked about it in class, and some of us wanted to write definition of segment bisector. I understand why you want that, or why you would want to write that, but we want to stay consistent with the terminology that is given. Since they gave us that it is a midpoint, we're going to use that throughout the proof. I think there's one in here. Oh, nope, I don't have one in here. But there are proofs that exist where it tells you that this segment is being bisected by another object. That's when you want to use a segment bisector, if they use that term in the given. So we're just going to stay consistent. We're going to use midpoint, so it's going to be definition of midpoint. So from there, that gives me that second piece about these 2 triangles that we're trying to prove are congruent. Our third piece, we had to rely on the diagram, and we see that these 2 triangles share segment LM, and we know that those are congruent because of the reflexive property of congruence. From there, I have my 3 facts listed, so I'm ready to say that these triangles are congruent. And again, this should just go along with my game plan. So yes, I'm going to write my 2 triangles are congruent because of side, side, side. So triangle JML is congruent to triangle KML because of side, side, side. Now, what you name these triangles is up to you, but again, the important part is matching up the corresponding vertices. So if you wanted to, you could have called this triangle MLJ. That's an appropriate name for this first triangle, but you have to make sure that your second triangle name matches. So vertex M goes with vertex M, vertex L goes with vertex L, and vertex J goes with vertex K. So just make sure that your letter order is matching. From there, I've proven my 2 triangles are congruent, and I know that these are corresponding parts of those 2 triangles that I've proven are congruent. So I can end my proof with saying that angle JLM is congruent to KLM because of CP/CTC. Now, with this, I don't want you to get into the habit of stopping at CP/CTC, because I could ask you to go on. So if we look at my diagram, we just got done proving that this angle here is congruent to this angle there. That's what we just got done proving. So that implies something. We could now say something else about this diagram. So what I'm saying is I could have asked you something else. I could have asked you to prove that segment LM bisects angle JLK. And so I could have added in a 6th step here that would have read segment LM bisects angle JLK. So you would have had to do the exact same proof those triangles are congruent, use CP/CTC, but now, because these angles are congruent, I can look and say, well, if these two parts are congruent, then this whole angle must be being bisected. And so this would be the definition of angle bisector. So there are other proofs like that on this page where you're going to prove triangles are congruent, you're going to use CP/CTC, but then you're going to take it a step further and say, okay, well, I've now proven this. What does that imply? What else could I say about these two triangles? And that's exactly what happens to the proof on the left. So I'll go over this one very quickly because I want to get to the other proofs that I haven't done in class already. So we have these three given pieces of information. They're already marked in your diagram for you. That was very kind. And so if I look, I say angle H is congruent to angle J. Those are marked. Segment GH is congruent to segment IJ. That's marked. And then I have those same segments are parallel. So it's already marked in our diagram. But let's see where we're going to. Where are we trying to get? We're trying to prove that these two segments are parallel. So we're not trying to show that things are congruent. So we're not going to end with CP/CTC. I got to find some way to prove that these lines are parallel. You know of about 5 or 6 ways of doing that. If you have two lines that are perpendicular to the same line, then that means they're parallel. You can find the slope of two lines. That's if you had the coordinates. If you knew the x and y values, if you knew those coordinates, you could use the slope formula. But what was on the first page of this packet, I asked you to list out the 4 ways of proving lines are parallel that are cut by a transversal. So if you have two lines that are cut by a transversal, you know of 4 ways proving those lines are parallel. And so we went over these in class before we even started proofs. But let's say I had these two lines and it was cut by a transversal. You know, so we'll say that this is line L, line A, and line X. So if I wanted to prove that line L was parallel to line A, and it's this situation where it's cut by a transversal, there's 4 ways of doing that. The first way, and these are all in the if-then form, is if corresponding angles congruent, then lines are parallel. What that means is you have 4 different pairs of corresponding angles within this diagram. So if you can show, let's go ahead and label these. If you can show that angle 1 is congruent to angle 5, those are corresponding. So if corresponding angles are congruent, then lines are parallel. Or if angle 4 is congruent to angle 6, those are corresponding angles. And if you can somehow prove that those angles are congruent, then lines are parallel. It also works with 3 and 7, and then 2 and 8. So that is one way of proving lines are parallel. That's if corresponding angles are congruent. Another way, and we've used this one quite a lot. I mean, we used it over and over and over again in Activity 15 and in Activity 16. And that is if alternate interior angles congruent, then you know lines are parallel. A lot of us are getting confused with, well, I don't know which one to put first. Do I start off saying lines are parallel, and then do I end with these angles being congruent? You have to think about what are you trying to prove and what are you trying to conclude. You know that these if-then statements, the first part is a hypothesis, and then the second part is a conclusion. So if you're trying to conclude that lines are parallel, then that needs to be your conclusion of this conditional statement, of this if-then statement. So back to number 2, if alternate interior angles are congruent, the lines are parallel. That would be in this diagram, like if angle 3 is congruent to angle 5. If you could somehow prove that, or if you were given that those angles are congruent, then you can conclude that lines are parallel. using this second reason. Also, you have angle 4 and angle 8. That's a different set of alternate interior angles. So we've used number 1 and number 2 a whole lot in this class, and especially in the past 4 weeks. The third way is if you can somehow prove or that you're given alternate exterior angles are congruent. An example of that would be like 2 and 6, and then 1 and 7. So if you can show that those are congruent, then you know lines are parallel. The last one is if you have same side interior angles. These are also called consecutive interior angles. We decided to call them in our class same side. That's what the textbook called them. So we're just going to keep consistent with that. If you can prove that same side interior angles are supplementary, then lines are parallel. So that's like if you can show angle 4 and angle 5. If you can show that these two sum up to be 180 degrees, that means they're supplementary, therefore lines are parallel. Same thing with 3 and 8. If you could show that those two angles are supplementary, which means they add up to be 180 degrees, then you know lines are parallel. So back to this proof. We're trying to prove lines are parallel, so we need to find one of those ways. How are we going to prove these lines are parallel? And you should have lots of arrows in your quiver to prove lines are parallel. You should have to pick which one is going to work in this case. These two lines here that we're trying to prove are parallel, I've outlined them and extended them. So you need to look at the different transversals that are cutting through both of these lines. We're going to focus on this transversal that's going to cross through those both lines. If I can somehow prove that this angle here is congruent to that angle, well, those two angles are corresponding angles with lines cut by transversal. Those are corresponding angles, and if corresponding angles are congruent, then lines are parallel. They also happen to be corresponding parts within these two triangles. So if I can prove these two triangles are congruent, then I can use CP/CTC to say that these two angles are congruent, and then I can use that first theorem we just talked about, that if corresponding angles are congruent, then lines are parallel. So that's my game plan. I'm given these two facts, that these angles are congruent and these segments are congruent. I need a third fact so that I can prove these two triangles are congruent. Well, I haven't used this fact yet. I haven't used this given. I used these two. Those are just freebies. They were already marked in my diagram. But I'm going to have to use this given. It's going to imply our third fact. And so if we look at these two lines here, we're going to try to find corresponding parts that are that we can say are congruent because these lines are parallel. The fact that these lines are parallel, that's not going to help me. That's not going to tell me that segment GI is congruent to segment IK. That's not going to help. Also, the fact that these lines are parallel, that doesn't tell me, it doesn't help me that segment HI is congruent to segment JK. But what that does tell me is that angle G here is congruent to angle JIK. So we're going to go ahead and use the three-letter process that angle G is HGI is congruent to angle JIK. And that is because if lines are parallel, then corresponding angles are congruent. So we're now talking about the converse of those statements that we were referring to earlier. So now I have my three facts about these two triangles, so I can prove that they are congruent using angle, side, angle. And then I can use CP/CTC to say that these angles are congruent, and then I can now show that those lines are parallel. So I've got my game plan, and now I'm just going to implement that game plan in the proof. So once again, it's so important, it's so vital that you come up with a game plan first, and then you just execute that. If you get stuck, you can look in the proof and maybe it'll give you some clues, but you need to come up with your own rather than just trying to dive in and trying to solve it and just kind of hoping for the best.